No, can I start now?
2 minutes.
I can't start now?
Sure, if you want.
I'm going to start a few minutes earlier. Hi, everyone. Thanks for coming. So, as you can see, this session is about Android and devices, focusing on the Internet of Things and Bluetooth Low Energy. My name is Dario Laverde. I'm very involved in the developer community in New York City. I run several meetups, including the Google Developer Group. And by day, I'm a developer evangelist for HTC. So I'm sort of wearing two hats on this talk. And what I want to talk about, in addition to targeting Internet of Things, is where, first of all, how many here are Android developers? Okay, cool. How many have developed with devices and Android using Bluetooth Low Energy? Okay. Okay, good. So I don't have to do some background on what wearables and what Internet of Things are. They've been around for quite some time, as you can see from this slide. In fact, there was a spec about the coffee on the internet. The obligatory chart, we all know IoT is going to be huge. IoT is the umbrella of wearables, bearables, nearables. I've heard all these terms. Bearables because it could be embedded in the body, not just over the body. And nearables are referencing devices like beacons and so forth. And of course, we have smartwatches. And over time, of course, we're not going to look as ridiculous as early adopters of glass and so forth. They're going to look like it's going to get better over time. So, Android. So we have all these technologies that can connect to the Internet of Things, whether it's Wi-Fi, Bluetooth, NFC. And more recently with Android, with 4.3, we had BLE, and 4.4, we have IR. I think a lot of people are ignoring the fact that we have that capability. So let me just review IR, because I think that deserves its own page here. This is essentially the API. And I don't think you can get as cheap as possible with the Internet of Things than IR, transmitter receiver. And it's obviously line of sight type of situation, but in some use cases, it's still very relevant to explore this API. So definitely take a look at Android Hardware Consumer IR Manager. So a little history on BLE, and I'm going to go fast through this because I know we only have 20 minutes. So please save any questions for after we leave the room. Low power, improved latency. If we look at the spec, it essentially is a subset of the Bluetooth 4.0 spec. So a lot of people like to interchange Bluetooth 4.0 with BLE. That's not true. It's an optional component of the spec. Here's just a comparison between the classic Bluetooth and BLE. We all know about the range obviously being a lot less because it's low powered, but you have a lot of improvements in latency, so that's significant. Also, the branding. So as of 2011, the Bluetooth SIG decided to brand this way so that if you have a device that's LE only, it's Bluetooth Smart. If it offers both modes, then it's Bluetooth Smart Ready. So most phones are Bluetooth Smart Ready. Now, the use cases, we all know that, from Fitbit devices, it's generally health and fitness type of apps. But of course, there's a lot of things that's open to our imagination, home automation, and so forth. And what the Bluetooth SIG has been driving is a set of profiles for all these common use cases. So what I have to really explain here is that these profiles are not specs. So that we have the Bluetooth spec, and you have to adhere to that to get certified. BLE profiles are more like guidelines as far as how to code for specific use cases and categories. The idea, again, here is to be able to say, if you have a Find Me device, if your app is programmed to support that profile, that it should be able to find any device that supports that profile. Of course, a lot of OEMs will try to put in proprietary characteristics and services that are perhaps not defined in a BLE profile. So in that case, they should do the right thing and publicly list what those characteristics and services are for third-party developers to develop against. So here's some sample use cases, profiles. Proximity sensing, that's a big area, a lot of devices there. So that uses the Find Me profile and the proximity profile. This is usually, I talk about a lot of this, the crowdsourced startups. Speaking of Find Me, like Stick and Find, like raised like almost $1 million on Kickstarter. So this essentially is the, the stack, and the profiles are on top of the generic attribute profile there. So again, I'm kind of zooming through a lot of this. So you have the basic components of BLE: attributes, services, characteristics. And services contain characteristics and so forth. But generally, the scenario is that you have a master and a slave. The master or central role is usually the phone, and the BLE smart device is usually a slave or peripheral role, although we have seen some devices that also run as master central roles. So right now, as of Android 5.0, we now support peripheral role. So we can actually have the phone play both of these roles. So the BLE protocols. So generally, servers expose these attributes and clients consume them. So generally, the client actions are to discover, to read and write, confirm an indication, and the server will respond and either synchronously or asynchronously using notifications to periodically send you information, like a heart rate. For all of the profiles and sample code and even videos, do check out developer.bluetooth.org as the central place for anything BLE related. Obviously, this on Google's Android developer portal, of course, you're going to have a lot of example code. Hopefully, a lot more than just a few example code. But here's just a few little snippets, just a general Android 4.3. You basically obtain a Bluetooth manager. You start a scan, and again, there's a lot of code in between this and just general outline. You obtain a device as a result of that scan, and then you obtain a Bluetooth GAT that will handle calls for discovering services, consequently discovering characteristics, and then you can call a number of methods to write characteristics, read characteristics, and a lot of it is callbacks that you handle when you read and write a characteristic. Those characteristics and how they're used are defined in each BLE profile. There is a number of developer kits, hardware-wise, that I recommend. It used to be that you had to spend thousands for developer kits. Now you can get a small device for like $25. Here's a sample Texas Instruments sensor tag that's got at least 6 sensors on there. And this is an example of, again, playing the roles, peripheral, central, and that's an app that's open source actually for you to develop against this specific device. And those are all the sensors available. Again, and like I said, OEMs don't have to adhere to that. But going back to before 4.3, a number of OEMs, of course, couldn't wait because iOS had the head start. And there were a lot of proprietary APIs for supporting BLE. Of course, now they're being deprecated, not completely removed, although that's happening as we speak. So that's one of the things you have to watch out for if you want to support BLE officially with the standard framework APIs. It's 4.3 and above. Here's one of the canonical example from the SDK is the Bluetooth GAT, and I have some additional extensions to it that adds more information on htcdev.com if you want to look at that. I'm also going to put some more additional samples on GitHub. And again, it becomes less of an issue supporting older than 4.3 as we move on ahead, because now we're up to 5.0. So in 5.0, a lot of there's thousands of new APIs. Just looking at the BLE APIs, there's over 140 last I counted, and I didn't really count the latest drop as of last Friday. But those, of course, the most important feature that a lot of BLE developers have been asking for is peripheral mode support. Because again, iOS had that for quite some time, and it really makes it able to support more devices. So you can test BLE, for example, from one phone to the other without having a device, although obviously it's best to have the device. And again, like I said, some devices run central mode. So you have new options. And as I was saying, as of last Friday when Android 5.0 officially dropped, there's even more changes from what the original preview in June had. And I highly recommend, if you're already doing Bluetooth programming, to always look at the diffs and then go through your code and see what the impact is and what additional options you have now. And they have diffs for going between 20 and 21 as well as from preview to 21. And a lot of this even affects, scanning for devices, advertising, because there's, in addition to the modes I mentioned, there's a broadcast mode where you can support having beacons, for example, the devices that just advertise, and there's like 3 channels where you can advertise on. So that's different from the BLE profiles I've been talking about, which is just the central and peripheral modes. So here's an example from HTC called HTC Fetch. So here's again, this is a Find Me device. You could attach it to your keys. I have my keys attached always to one, so I never lose them. So basically this app, I just want to talk a little bit about this app because I authored this app for HTC. And basically, it functions as, it gives you the ability to not just find devices, but the device itself has a button so you can find your phone. So the functionality here is you can locate, obviously, where you last connected if you should have lost your keys. You can send different levels of sounds to the device. And again, you can find your phone as well. And there's other services like how much battery is left on the device and so forth. So in the process of developing this, and again, this was against the 4.3 API, I'm going to go over some of the gotchas that I discovered, but just a little more. And again, this information is available on htcdev.com. I also will make the slides available. We decided to really open it up to developers to program for this device. So we're supporting standard BLE profiles. Again, they're not specs, they're recommended. So Find Me profile, proximity profile, and like I mentioned, the battery service is supported. What we had to introduce was something that wasn't found in any of the other profiles, which is the ability to find your phone by pressing a button here and sending basically a message the other direction. And so we published the service and the characteristic for being able to do that. So some of the gotchas, I don't know whether to call this practices. So one of the first things if you've been developing for classic Bluetooth and you start working on BLEs, you have to treat the device differently. You don't assume you can switch modes as quickly. You have to remember it's low powered. You will quickly drain these watch batteries, the standard ones, very quickly, quicker than you expect. And part of the problem is that the end user will always pair to one device. As you're testing, you'll find yourself switching from one device to the other, which is not a common use case, but it's common while developing. So you have to remember you have to completely reset the devices, and all that scanning, of course, is going to drain the battery. You have to acknowledge reads and writes. There's the callbacks, and yes, technically everything should be asynchronous, but in practice it really isn't. It depends on the implementation of the stack. Different phones will handle things differently. So your safest bet is to always acknowledge every callback for every read, every write. Always implement retries. Always handle timeouts. That's very important. Store and manage device addresses. Oh yeah, try to avoid scanning all the time. Try to store all the information so you can quickly reconnect. When you connect to a device, there's two modes actually. To have basically a reconnect happen automatically, or for you to tell it to disconnect and connect on demand. So those are the two modes you have to be careful when developing. Test against as many devices. Of course, you know this as an Android developer. But specifically for BLE, there's going to be some OEM workarounds for specific OEMs. I don't want to mention names. All right, I'll mention Samsung. So you have to make sure that some calls require a separate thread. Some calls, you shouldn't call in the main thread. In some cases, it's not obvious, but there are workarounds. And this is specific, in this case, was to a reconnect issue. Oh yeah, the GAT object. So all your Hello World examples simply work with one device, and they work with discovering the services. And it's great for exploring what services and characteristics are, but when you want to manage multiple devices, then you have to remember that you can't assume that one GAT object per connection. You need not one object for all connections, but you need a GAT per connection. And as I mentioned, I haven't mentioned this. But you have to make a decision about how much you want to support older devices. I mentioned that so far as going before 4.3, but also before 4.4.3, because that release included a lot of BLE fixes. There was a major issue with a MAC address pool exhaustion, where if you connected to enough MAC addresses, then your stack would basically blow up, and you'd have to restart the stack or restart the device. Fortunately, that was fixed in 4.4.3, but you have to be aware that if you're targeting before 4.4.3, that could happen, so you have to just keep that in mind. I want to talk about another HTC device. We just announced it very recently. It's in fact right here if you want to check it out later. The RE camera, another Internet of Thing. Basically, it's a remote camera that allows you to take pictures, videos, slow-mo videos. Basically, it uses BLE and Wi-Fi Direct. And currently, we are opening up APIs. Initially, we're just basically providing the intents, which are these, for being able to remotely take pictures from your app and, of course, retrieve the media from the device. There will be a full SDK forthcoming, and that will be available on htcdev.com. Other things that, this is just a screenshot of what the app looks like. And again, BLE is used for initial discovery and connection control and connection management and so forth. It allows you to negotiate the Wi-Fi direct connection to provide the real-time video streaming to your phone and eventually out to the internet. Other IoT devices with BLE, beacons is a popular subject. Now that we have peripheral mode and more advertising APIs, it's going to be easier. But currently, before 5.0, there were a couple open source projects that you can definitely check out. I've used the Radius Networks one for writing apps, BLE apps that discover beacons such as this one, the Roximity beacon. And again, this is not a new protocol. This is technically iBeacon protocol. Beware that, of course, Qualcomm has its own protocol, and there may be other third-party protocols that are not quite compatible. But again, open source is great because you see some of them will also have branches to support like the latest Android 5 APIs. Now I'm going to quickly switch gears to some wearables, Android Wear and Google Glass. And I want to talk about internals. And when I say internals, I mean not the hardware, but the AOSP-based Android underlying it. What I want to talk about is for more advanced developers, if you're playing with new devices or if you want to explore outside of the given frameworks provided to you by Android Wear and Google Glass, that you can, since it's based not 100%, but mostly on AOSP code, you can start exploring by, obviously you would need to break warranties and root the device. And normally I'm anti-root, modded ROMs that come with root enabled. Users should never need root, so that's something I want to emphasize. Developers should. It's a great way of learning, experimenting, bug fixes, workarounds, so forth. I'm going to speed through a lot of this because basically my time has run out. But again, this is available. This is details on how you can actually unlock and your Google Glass, void the warranty. This is me actually voiding my Google Glass warranty right there. And fortunately, with Google Glass, you have a boot image. The kernel is available as well. You can build it. You can. Again, this is details. Back in March, I didn't want to wait for a device, so basically, when Android Wear preview was released, I decided to hack a third-party watch that's available on the market. There's plenty of Android smartwatches on the market pre-Android Wear. That's why Android Wear kind of exists, just because we need a standard. But I decided to get one because I think emulators are not doesn't provide you the real experience. Just like on Google Glass, you need to actually wear it to have the user experience consideration. I picked a specific one only because it was cheap and had a nice spec. It was easy to use, and these are the steps if you want to actually work on that specific watch. And that's that watch running Android Wear preview before Android Wear was available. But one of the things I want to point out here is that even before Android Wear was officially announced, a lot of these Android watches had similar approaches by using the Bluetooth framework that, as of 4.3, allowed you to display notifications remotely to another device. So this is the actual wording from 4.3 release notes. So they had that in mind for devices. So that was coming. So I just thought about some of the limitations and some of the commonalities with that. So now that we have our official release, of course, and actual retail devices like this one, you can try to also experiment and root it, and these are steps for extracting and basically setting boot enabled and so forth. But what I want to talk about is why you want to go through all this trouble, because there's a lot of ideas out there, and some of them are alternate interfaces, for example, and having. So recently I got a Mayo, and they do have a Google Glass input sample code, except you can only use it within one app. So one of the things I started doing was to try to have that as an alternate input to Google Glass, because in Google Glass, of course, you have to tap on it or talk to it. Suppose you want to be more discreet. You can use the Maya wristband, which you can move your fingers to and send it commands discreetly. But to do that as a system-wide input, you have to, of course, play with the framework. That's why you need to actually go into the internals. Another thing I've also played with was the NeuroSky headset called Mindwave. So you can even do nothing at all, and just hopefully eventually just think of commands and have them control your devices. a lot of people are working in this area, so we'll see if that can become a reality. Or you can experiment with UIs, maybe run Glass on a watch or Android Wear on Glass and so forth. And that's about it. That's my presentation. So I know we've kind of run out of time, but I can take some Q&A right now, or we can have Q&A right outside the room.
Question.
Yeah.
When you've got these beacons broadcasting, how expensive is it to hold for when you're within range of one of these beacons?
So there's two modes. One is a very inexpensive, but it's for detecting that you're in the area. Then once you've discovered it, then you switch to a fast mode, and then you can really try to determine where it is.
So that determines ranging for it.
Yes. Any other questions? Well, thanks again.